Yes, sir.
Okay, so the first day of the class, for the chemistry, we are gonna go directly to teach. Okay, I usually go the syllabi when I teach the first day of the class. We have two textbooks recommended you to use, which is already on the eCampus. This is called the Principles for the Chemistry. It's fourth edition. When you read, it's relatively easy to understand, but I tell you there are some mistakes there, and I will point it out. But most of the people think about the Bible for the chemistry class is Fennemer for the Chemistry 4th edition. This is by Dr. Fennemer. He is originally is a university distinguished professor at the University of Wisconsin-Madison. This is a very heavy. It talks very details, every single piece for the chemistry, and we're gonna teach part of that, but not gonna be from the detail from the beginning to the end. Okay, these two are on the eCampus. The class, we will do a very flexible and a very friendly environment. So we have 3 exams. So first exam will be an open book, semi-open book, which means you will be here. You can use all the resources to do, except search online. The second exam we will do always is assuming you are a faculty in working the university. Then you're gonna create the exam questions for students. So you're gonna generate an exam paper. Then have the questions and do the justification. Why that's a good question, what is the answer for that, and which chapter of the textbook where we're gonna find the answer. Then the last one we will do is traditional like homework, the final exam. Besides that, we will have a guest speaker, Dr. Kenny will be here to talk about protein. Dr. Martak will talk about IPSP, and I try to find Connor here to talk about his experiences after graduate with a nutrition dietetic internship, what he is doing about the chemistry, anything related to chemistry for his job. And then we also gonna do a very traditional presentation. You're gonna pick 3 or 2 literature review. The published paper, we do a literature review, and then you make the slides, do the presentation. That could be related to your research if you're graduate students. If you're undergraduate, you could be doing something for the literature review. Or if your capstones related to capstone topics. Anything related to the chemistry, which is fine. Okay, so that's what we have for the syllabi introduction. But when we talk about the first class, we will be mention the material what we're gonna focus and emphasize in the during this semester. So the first class, or we can say the first week, we're gonna do an introduction overview of the chemistry. And then on Thursday, we will usually go over the basic knowledge of the of the biochemistry. Then start from next week, we talk about the detail of the food chemistry, about water, started from water and ice. Okay, so today we want to talk about is introduction of chemicals, or we say chemical knowledges. I have a slides. We will go over it when we do the review, but most of the time I will just draw on the blackboard because that's easy to understand. So the first question I always ask students when you're taking this class, what this means. That's very basic high school knowledge. C, you have 6, you have 12. So what is C? That is carbon. And we call, this is a biological body skeleton. which means the carbon chemical is important for the biological body. Now what does 6 means? That's a proton number. And what does 12 means? We call it a mass number. So if you still remember these things, I said your chemistry are fine. If you don't know these 3 items, then I make a joke. I said you should drop off the class because looks like you're not prepared anything. Okay, so then we talk about that. So we have C612. What this tells us is this guy. Okay, we have an atom. Then inside of the atom, what we have? We have this center. This center we have proton. And another one we call it a neutron. So first of all, this atom should be no charge, ideally. And the proton is always positively charged. And the neutron is no charge. But then, where is the negative charge comes? The negative charge comes from a heavy, like a cloud, surrounded the center. That is called electron. And we also call electron cloud. And this, we're going to spending a lot of time today talk about that. Because it is important, and I will tell you why it is important. So let's talk about that proton. Proton is positively charged. Neutron, no charge. Most of the time, the proton number equals neutron number. But there is an exception. For example, hydrogen. The proton is 1, the neutron is 0. There is no neutron. There is also some exception. So for example, you have H3, you have iodine 125, you have N15. These, the proton number and the neutron number are not the same. Then comes out with a terminology called isotopes. Now, some of the isotopes is related to radiation. So let's say this iodine. It's used to develop a method called RIA, radiation immunoassay. This is used to testing hormone in the blood cells in the old time. Another method people can use is lesson. Same as H3. How about N15? And you should be still remember. We have a double strand of DNA. Okay, originally we were labeled in N14. Okay, I should use a yellow one. And it's N14. And then you try to let them grow with a media rich with N15. And then what happened? This guy separated, these two separated, and then this comes out, and this becomes N15, this is N15, and this is N14, that is N14, and on and on and on. And later on what happened? There will be more than 75% components is N15, less than 25% is N14. This comes out with a very important research in the history of the biochemistry is Mendelssohn star experiment, and this used to confirm the semi-conservative DNA replication. So this is something is important. So we want to review the proton, neutron, this basic knowledge. So not done yet. Let's still review some of the important atoms composed by a biological body. So let's do a table. So we have an atom. Okay, we have a proton number, and we have a mass number, and this will be a percentage. So we talk about the proton. So H, proton number is 1, mass number is 1. Okay, how many percentage of H in the body, in a biological body? Very close to 50%. Very close, 49%. What is the second one? That's C. That's carbon. Proton number 6, mass number 12. That is about 24 to 25%. What is the next chemical is important? Oxygen. That is 8. The proton number. The mass number is 16. How many percentage? Around 24, 25. So these three alone, the percentage is about 99%. HCO, while we say CHO, comes out with this guy. We call carbohydrate. This will be our chapter 3, or will be a major topic. We'll talk about carbohydrate in this class. Especially we will talk about the table sugar, the manufacturing. How are we going to manufacture the carbohydrates, the table sugar? Okay, so we have a 99% HCO. What are the other stuff? Okay, what about then? Nitrogen, proton 7, mass number 14. This is about maybe 0.1 to 0.5%. What are the other chemicals important? Phosphate. This is 15, that is 31, a little bit tricky. Also 0.1 to 0.5%. What's the last one? Sulfide. Okay, 16, proton number, mass number 32. Add up together, also 0.1, 0.5%. If you add up these together, this is around 0.9%. So nitrogen, phosphate, and sulfide, these are also important. So these add up together, the 6 atoms responsible for 99.9% of the atoms in a biological body. So that's the atoms in a biological significant body. How about the left 0.1%? What are they? Well, that's the other things we talk. It could be sodium. We'll talk about sodium chloride very quick. It could be chloride, it could be ferric, it could be magnesium, it could be calcium. When we talk about the water, we will mention the hot water and the soft water. So we'll talk about the amount and the percentage of the magnesium and the calcium. And you may have some other chemicals, potassium. Okay, so these and on, or lots of them, lots of the other atoms. That is about 0.1%. Okay, so we reviewed proton, neutron, talk about the isotopes, talk about the major 6 atoms composed by a biological significant body. We haven't talked about is here, the crowd area, is the electron. So we want to spend time talk about it, the electron. Okay. There will be a couple of classes or a 1 month classes for your chemistry. And we will just do a very brief review using 15-20 minutes. Okay, we'll talk about the electron. So this is the center. We have proton, we have neutron. Then outside we surrounded by electron. An electron has a multiple layer. And we know that. Multiple layer there. Okay, we just do several examples. That's called K, L, M, N, O. Corresponding to the Arabic number is 1, 2, 3, 4, 5. Now this is called the layer. We also had a sublayer orbital, which means inside here you're gonna have S, P, D, F, all the others. And we always know that the arrangement of the electron is a big topic in the chemistry. And they always arrange from inside of the core area of the atom to the outside, which means they from the lower to higher energy level, and they try to keep the whole status, the energy status of atom is at the low minimum level as possible. So we talk about the K, L, M, N, O. We want to talk about here because that's what we are interested about that. Okay, so the first question, why we want to talk about that? If we go to the chapter 1 of food chemistry, we talk about the water. Let's say we talk about this water. The textbook will tell you this is tetrahedral arrangement and sp3 hybridization. Okay. Then, if in the exam you will be just remember that. But what this means. So when I first prepared the class, I forgot about it. So I think if we want to explain with really good understanding of the sp3 hybridization, we need to go back to talk about the electron cloud surrounding the atom and the neutron and this basic chemistry. So that's why we need to introduce it to you. Otherwise, all of a sudden, you see this sentence in the food chemistry textbook, which is very confusing, and you're not going to be understanding very well. And in the food chemistry textbook, you will see there are all these type of the terminology comes out because they assuming you already have a strong foundation of chemistry. Plus that, we need to talk about a little bit of physics, a little bit of math, obvious about biochemistry and biology. So that's why we want to talk. Okay, so how we want to understand that? Then a very good formula we can talk. So using N, this is the number of energy layer. And then we have a number is L. That is a number of shape of sublayer orbitals. And the formula is very interesting, is L less than, equal or less than n minus 1. So this gives you some interesting interesting topics we can focus on. If k equals 1, which means n equals 1, okay? What's the number of L? The L can only be 0. Z is corresponding to S layer, S sublayer. What is the shape of the S sublayer? It's a circle. So we call it a sphere. Okay, then we do second one. Second one is L equals 2. Corresponding to n equals 2. Then what's the possible value of L? The L could be equals 0 or could be 1. 0 is sphere, S layer, we already talked about. How about 1? I'll just say all 1. This 1 will correspond to P. What is the shape of the sublayer of P looks like? It looks like this. We call it a dumbbell. Now it's become complicated. Because it looks like a dumbbell, so there is 3 different directions. It could be straight, perpendicular, this is called y-axis, basic mass. It could be horizontally, so that become x-axis. And it also could be a 45-degree angle, that is z-axis. So therefore, the p sublayer orbital have 3 directions. Okay, then we go m equals 3. Okay, what we have? That's n equals 3. That L could be 0, could be 1, we already talked. That could be 2. So we talk about already is S, is P, that could be D. Okay, how many directions? They're going to be drawn just like this, like a flower. There are 5 directions. Basically, we cannot draw it. We just draw a flower. Okay. Let's give an example. If n equals 4, that's n equals 4. The L could be 0, 1, 2, and 3. If it is 3 SPD, what's the layer is that? That's F. F looks like that. I'll just draw like this. 7 directions. So that's what SPDF means. So that's a basic. Okay, then we go to see. What is SP3, SP1, SP2 talks about? We're not going to mention hybridization today. We're going to talk about when we talk about the first lecture of the water. But we're going to just introduce to you. Then we go to a core section of the chemistry about the electron layer. That's the arrangement of electron in sub-layer orbital. So, the arrangement of electron in sub-layer orbital. 3 rules. Rule number 1. That's what we call minimum energy policy. You have a name for that. I don't want to talk too much. That's easy to understand. The electron in the sublayer orbital is always from lower to higher energy. The idea is to keep the whole status in a lower energy as much as they can. Basically, they follow the number. But there is a jumping could happen. And we'll give you example. That's rule number 1. Okay, we want to talk about rule number 2. This is in the chemistry. We talk Pauli exclusion policy. So what is that? What means Pauli exclusion policy? I'll give you example. I have 1s, I have 2s. What are they looks like? Up and down. The electron is up and down. So what this means? That means each sub-layer orbital can be maximal occupied by 2 electrons and spin opposite direction. That's Pauli exclusion policy. That's why they spin opposite direction. And the sublayer can be maximum only 2, no more than that. So who is Pauli? A great chemist, born in Austria. He immigrated to the United States, is a U.S. citizenship, and died in Switzerland. So one person, 3 nationality. He had a very short life, 1901 to 1959, only 58 years old. But he won the Nobel Prize in 1945. So Pauli exclusion policy is 1945 Nobel Prize nominated by the great Albert Einstein. So you don't think about this is very easy. Right now we have all kinds of tools we can do. Microscope, chromatographer. In the old time, you spend lots of the energy to do that. That's Pauli exclusion policy. Okay, rule number 3. This is everybody knows, pretty much. Hans rules. Hans rules. So what does Hans rules mean? Let's give you an example. Okay, I'm going to draw, yes, P layer. Let's say 2P. Okay, I have a first electron goes. Then where the second electron gonna go? Is that gonna go here? Or it's gonna go here? Well, the second one. Yeah, that's correct. So what this means? Okay, that means the Hans rule can explain that. Sub-layer orbital. First, singly occupied before double occupied. always remember the Pauli exclusion policy and the Hans rules has to be combined together. Hans, a great German scientist, 1894 to 1997, 103 years old, very long. But this one doesn't end up with any words, unfortunately, but it's important. Okay, so we have rule 1, rule 2, rule 3. Basically, we talk about the rule 2 and rule 3. Okay, let's do some of the examples. Just do some of the examples. Okay, I have several examples here. We want to talk about that. So number 1, C612. What are going to be the arrangement looks like? One box, second box, third box. So 1s, 2s, and 2p. So what it looks like? Up, down, up, down. There you go. Up, you go up. So what's that? So 1s2, 2s2, and 2p2. That's carbon. Okay, next one. Nitrogen. Nitrogen is simple. We go here, so we go here. Okay, so 1s, 2s, 2p. These are the same. Up, down, go up, go down, spin opposite direction. Up, up, up. Why these all have to be occupied? Because Hans rules. Sublayer orbital, first singly occupied before double occupied. So this becomes 1s2, 2s2, and 2p3. Okay, let's go to the next one. Easy. Oxygen. 8 and 16. So we're going to do draw again. One S2, 2s2, 2p. Okay, so up, go down, then go up, then go down. Okay, this is up, up, up. Hans rules, then go down, Pauli exclusion policy. So that's 1s2, 2s2, and 2p4. Okay, let's jump in. Let's do something a little bit difficult. Phosphate. This is going to be a tough one. Okay, so what you do? Go, small box, large box. So 1s2, 2s2, 2p. So you're going to go 3s. So you go 3p. Okay, that's 15. So obviously here, they are all going to be occupied. There's no question about that. Because 2 plus 2 equals 4, and 4 plus 6 equals 10. So we go here, sorry. Up, up. So we go down, and this is up, this is down, so that's 12. To the last one, up, up, up. Okay, so that is 1s2, 2s2, 2p6, 2p6, 3s2, 3p4. 3p3, sorry. Okay, that's phosphate. Let's do the last one. I promise you the last one, but it is important. Potassium, K19 and 38. That will be in the chemistry exam all the time. What happened? Then we do 1s, 2s, 2p, okay, 3s, 3p, okay, then you have here, then you have here, so let's do 1s, 2s, 2p, 3s, 3p, So let me see. That's going to be the 3D. Yes, 3D. Sorry. There's some other mistake here. 1, 2, 3, 5, 3D, and the last one, 4S. Okay, what happened? This is easy. Up, down, up, down. And we just fill up all these, okay? It's easy. That's not difficult. That's 10 right here. Up, down. So we're also going to fill up here. How many we have? That's 18. This is 19. Then this gives you trouble. Where this should go? Theoretically, it goes here. But it's not. It goes here. This is what happened is when they come out with the Pauli exclusion policy Hans rules, they think theoretically that should be 3D. However, when they use chromatographer and those old chemical microscope, they find it is as 4S. So potential happened is electron jumping. So that's very interesting. And this one, if you want to write, is 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s1. Now, why they do a jumping? Because the idea is that they want to keep the electron at the minimum energy level as possible. Okay, so we mentioned all these. We're really quick to review. In the chemistry class, we'll teach about the months, we'll teach about several classes. But what we are going to be doing some of the conclusion here. It's very simple. There are two rules talk about electron. If we talk about biological activity chemicals, number one we call it the octet policy or octet rules, which means most of the chemicals, if they have interaction with other chemicals, they always keep 8 electrons in their outer layer. So that's a very significant for a biological activity body. The second one we call it a valence. What that means, the outer layer electron is easily to be engaged with other chemicals and to forming, or to say, easily engaged with other atoms to forming chemical bonds. So, the next question, Corey, can you move a little bit? We're going to be doing on the other side. So the next question will be talk about the chemical bonds. Okay, so we're going to talk about the chemical bonds. This is also something will be mentioned in the biochemistry class, for the chemistry class all the time. So we're going to move on to talk about the chemical bonds. Roughly we have 15 minutes left. By the way, I usually will off the class around 1:30 or 1:35 because I have another class 2 o'clock. I need a little rest. Okay, so we're not going to be finished until like 1:45, 10 minutes earlier. Okay, chemical bonds. First one. Ionic bonds. This is everybody knows. A very common used chemical in the lab is sodium chloride. Sodium chloride composed by sodium and chloride with ionic bonds. So what happened? This is positively charged, that is negatively charged, and they could be attracted with each other. And we gave them a terminology. The sodium, we call it cations, positively charged. This is anions, negatively charged. So if you want to draw called Lewis model, what going to be looks like, this will be 7 electrons outside in the outer layer of a chloride, and then one of them donated from sodium, and they combine. Sodium chloride is very simple, but we will talk in the water section because if they going through electrolyzed process, will generate electrolyzed water, and then we'll have generate a newly developed sanitizer and also antimicrobials. Not really new, it's been in the recent 20-30 years, but compared to chlorine, that's relatively new. So we will mention about that in our water section. Because I'm a microbiologist and I'm interested about those antimicrobials. But some of the chemicals, we certainly want to talk about that. So ionic bonds. Second one, covalent bonds. So what is covalent bonds means? Ionic bonds, they are attracted with each other between cations and anions. Covalent bonds, they are sharing electrons. So I give you a very simple example, is proton with a carbon, then become a very interesting material. Yes, everybody knows, but you didn't realize it too much. H, that is CH4. What's that? That's messy.
Is it HH or 4H?
This is in the older time, is going through fermentation process, will generate electricity. This is the combination, is covalent bonds. Another one we will mention in our water section is the water structure. You're using delta positive, delta negative. This 104.5 degree. This is covalent bonds. So covalent bonds, we talk about sharing electrons. Although they share something, but their capability to attracting the electron is different. This comes out with another important concept called electron negativity. And electron negativity have a value for some major chemicals. So for example, proton is 21. Carbon is 25. Nitrogen 30. Oxygen 35. So they have a different combination. If the combination is H and H, H and C, and C and C, we will say they are approximately equally share electron. We call non-polar. But how about the other combination? If it comes out with H with O, H with nitrogen, C with nitrogen, C with oxygen, this is non-equally sharing. So we call it polar. Who is a major scientist mentioned or pointed out electronegativity concept? This is should be on my right. There is Linus Pauling. We will mention him all the time. Linus Pauling. 1901 to 1994. Linus Pauling is a great chemist. He has 2 Nobel Prizes. One is in 1940s because of the sp3 hybridization coupled with electronegativity. But his major contribution is another one is a Nobel Peaceful Prize. That is in the 1960s. Because he with other scientists, basically in America, and sent a petition letter to President Eisenhower and to oppose use nuclear weapon during the war. So he has 2 major Nobel Prize, and a great person. We talk about that all the time. He did have up and down in his life. What happened is he's also the person in the competition to find the DNA double helix. And he find that the double helix